So again, this is Sam, this is me.
Hi.
We are mobile developers. We work in Last Minute. If you don't know, Last Minute is the top, the leader in the market when it comes to the dynamic packages and holiday. So if you are looking for your next holiday, please take a look at the page. But like, this meeting is about tech, and we love speaking about tech. If you are wondering like what we do from time to time, like all the developers, I have some mates around, we tend to write some of our histories in the tech blog. That's the link if you want to visit. But we're here about the, as he said, the dependency injection, dependency inversion, and we have some agenda, like what's the goal? Like we're going to get through some of the theory, some of the strategies, and a conclusion in a bit. But let me tell you a bit of a story on how we reached this place. So, as I said, we are both mobile engineers, and we work with React Native. In React Native, it's pretty easy to come up and create some UI. You can create functional components, and in the end, it's translated into a user interface that covers the UI layer over there in the top. Then, if you've been in the previous talk, they presented a hook. Hook means you can add some behavior to these components, and with these hooks, we can like hook, right? Our business logic into there, and more or less covers our domain between those hooks and some functions we put. In the end, at the very bottom, we have our third-party dependencies, which means data layer, I don't know, HTTP client, databases, Firebase, whatever dependencies you want to work with in the background. There's a third-party dependency over there, and we usually bind it through a data model or some data layer we want to cover. I don't know, if thinking about an example, tracking interface is pretty easy. Like you pick a dependency like Firebase, you create an object, you use their API to track an event. Easy, right? So when we were invited to the Code Motion, I was looking for a hot topic, trendy, and while looking, we don't really have something interesting because React Native is there some quite time ago. And I started Googling, and most of the topics are AI elements, like nothing fancy over there. So I said, okay, let's try to force it a bit, put something interesting, and what if we switch the library of the tracking of our tracking and start prompting something, right? This is more cool. This is something I can present in Code Motion. So in the end, I started working on it, creating a presentation. So I switched my third-party dependency to be this new one, and I switched my data object to work with this new API. But in this project we're working, I found a challenge I was not expecting. The API was spread around on my domain, like everywhere. I had to refactor a lot of hooks, and sometimes even reaching the UI. So I couldn't really make it. But that gave me like the introduction for this new topic we're going to speak today, and Sam helped me a lot, and with her we will find out what it's about.
Thank you, Ali. Quite the predicament, not clickbaity at all, but it has some solutions. If we want to stop backtracking upwards in our dependency tree, there are some things that we can do, right? So before we get to the answer of that question, let me introduce you to a couple of concepts in case you're not familiar with inversion of control and dependency injection, right? So what's inversion of control? Basically, it's a software design principle in which the control over a component's dependencies is going to be transferred to an external entity. What does that mean? That means that it will receive the dependencies from the outside, often through dependency injection, which is our next topic. So dependency injection is a form of inversion of control that allows you to have separation of concerns if you had the chance to attend the previous talk. They talked about this. It was pretty interesting. And what that means is an element will use other elements, aka the dependencies, without worrying about the details. These dependencies, of course, don't come from nothing. They are going to be provided by an injector. You can call it whatever you want, container, provider. It can be anything you like. Because in the end, what we want is to achieve a well-structured app, like don't we all? But what does that look like really? So in order for us to answer that question, we need to take into account our base components, which will be the UI, the data, and the domain, right? And if you had the chance of going to Roberto's talk, and I forgot the other name, I'm so sorry, the 1.0 guys, they talked about loose coupling a lot, and if that's bad or good, it depends really. But in our case, which is the mobile app specifically, we would like to be very loosely coupled between the components, which means that they are going to interact with each other as little as possible for us to minimize potential problems. And the second topic is that the dependency flow should never travel upwards, like we saw before in our example. It should always travel downwards, or sideways if you really can't help it. So you should always be doing this, in theory, and never this. But what does that mean? In order for us to answer that question, let's take a look at this diagram we made, an adaptation of the clean code architecture, which we probably have seen 1,000 times by now. If you had the chance of going to Cesar's talk earlier today, I feel a little bit called out because he said, you know, front-end developers love concentric circles. And I was like, I do. I'm sorry. I also use glasses to appear more intelligent. I don't know. So how do we get there? Anyway, it is true. The UI and data layers are in the outside. We decided to use Zustand for store and state management. So that's going to be in the middle. And then at the center of it all, we're going to have our use cases, which is our domain. So how do we achieve this inversion? In theory, what we want is to define abstractions inside the most inner components, aka our domain, and then implement that abstraction in our data layer, which would be the outer layer. What does this mean? This means that a contract will be defined. If you define a contract, that means that you have some rules that have to be obeyed and respected by both parts. And that guarantees integrity and that you won't have to modify the inner layers to achieve changes. That way, replacing components from the outer layers becomes much easier and safer. So, going back to our previous example here, in which we will have to modify basically everything to achieve a new tracker prompt.
My prompt, yeah.
Beautiful prompt. Let's not look at it this way. Let's look at it instead this way. Basically, it's the same diagram, same components, and same interactions. But let's try to apply what we just discussed and define an interface within the domain, right? So the first thing we want to do is expand our domain, right? And then declare the interface there. And then the data layer, instead of having the implementation there, will be obeying the interface created by the domain, which is keeping the contract we made. That way, if a new third-party dependency comes along, like our great ChatGPT wrapper, then we could remove the old one and just adapt to the new dependency we have. And boom, just like that, we achieve inversion of control. It all sounds really easy, right? Because it sort of is. It depends. We're going to see. So why am I telling you this? Why does it matter? Why should you do it? Well, first, it's cleaner code. We all have seen it. You want to detach logic from implementation, and this allows you to do it. This makes your components easier to test, right? And that translates to having faster development cycles. Because if you have a contract that needs to be respected by both parts, that means that you can have one person working in the domain layer and one person working in the data layer in parallel, and that's faster. And of course, product managers love that. And that translates to real business impact, because you, in theory, will have fewer bugs if you do this. Don't take my word for it, but it should be. It will be faster to implement things, and you will have a code base that's resistant to change, and you will be able to adapt to new product needs. I know that in JavaScript or TypeScript, this topic might not be too talked about, and that's probably because when JavaScript came out, it wasn't created with types or this type of abstractions in mind, and basically nobody gave a about it. But it gives you leverage to solve real problems in real life. If you have used other frameworks, other tools, basically anything other than React, you probably are already familiar with this. So maybe we could do it also in the front end, right? I do love yoga, I'm not gonna lie. So let's see if we can do some yoga for our core. I love this channel, follow it, it's great. So the keyword here is flexibility. Because what is our goal in the end? Our goal is to achieve a domain that's as agnostic as possible, as close to 100% as we can get. If you do that, you can replace other components easily, and it gives you flexibility to change third-party dependencies whenever you need. And that is great. I love that for us, because it's backed up by solid principles, which we all know and love. It's scalable through clean architecture, and we all love scalability. And it really keeps your domain reusable, and again, flexible, don't forget. Of course, this doesn't come from nothing. We're gonna have to create some kind of dependency injection tool for us to support this decision and support scalability. And we're gonna get to that in a minute. Let's take a look at this example. It's a little bit more complex, but hopefully you'll bear with me. So let's say, since we're lastminute.com and we are a travel app, let's say that the user opens up their app and tries to refresh the list of their trips. So in theory, we have two core features here, which would be the trips feature and the tracking feature. Because in theory, when the user opens the app and tries to refresh their trips, what will happen? Many things will happen. The first of them would be, of course, we call the load trips function to retrieve the user's trips. But then we're gonna have to use our beautiful tracking service to report the event that just happened, right? So the dependency flow here is not too bad, because in theory, we have already achieved inversion of control, and we're implementing abstractions defined within our domain, right? And then we have some provisions, or index files, whatever you want to call them. We like to call them provisions, because that's exactly what we're doing. We're making them available for other components to use. And we can't forget to have them in some sort of registry for them to be accessed later. So everything now would be englobed within the app module, right? So now we're going to get to the strategies we can apply to achieve this dependency inversion. So we're talking about our dependency injection tool right here. Sadly, it doesn't come for free. We have to implement it. So we'll highlight some options we're going to go through today. Basically, we're going to review dependency inversion, which we just discussed. We're going to talk about injected singletons, factory methods, service locators, dependency injection, and everyone's favorite, if you have used React, context API. For this, we prepared a repo for you. You can download it, please do. It has one branch for each solution that we're going to go through today, so you can even follow along if you like. I'm gonna give you guys a minute while I drink water so that you can scan that. I mean, you have to take a minute to look at this beautiful UI. It's unmatched. So here in this app that we prepared, we have basically two functionalities or two screens. One to list the user's trips and one to list the user's profile, right? First, to start, let's say that we didn't do any kind of dependency inversion at all. And let's take a look at our main branch, which has this function to load the user, right? Since I mentioned we're using Sustant, this function is basically going to retrieve the information and set it in the user store, right? Oh no, what do we have here? We're using the profile store directly, and it's living inside the data layer.
And I left a to-do over there. We love to-dos.
We do love to-dos. So we really shouldn't be instantiating that there, right? We really should be injecting the dependency. So how do we do it? Let's start right in the beginning with the basic dependency inversion we were discussing. So according to what we just discussed, we should be defining an interface within the domain. and that would be the profile store we defined here. I highlight the diffs so that you can basically see what changes between one step and the next. So basically, we create our interface as generic as we can, right? And then, instead of accessing directly, we're just going to import this abstraction that we defined. But what's important here, if we look at the diff, is that now profile store is not being accessed directly, it's being passed as a parameter of this type. So that's the basic one we just discussed, but we can do better than that, right? So let's go one step further and apply injected singletons instead. What we're going to do is we're going to have some index files. We decided to call them provisions. And that way, we're going to register what's going to be exported and be made available for other components to use. That's good, because that's going to give us an initial order to be respected for the rest of our dependency injection strategies. But we could do better than that, right? Because the only downside I see to this type of approach is that we can't really manage the lifespan of this. So once you export it, it will basically live forever, and you can't really override that dependency. If you had the fortune of going to Eugenio's talk yesterday, that's really costing us and to the environment, and we're draining Africa. So we really shouldn't be doing that. So remember, we need to mock the dependency if you want to test. So we can do better than that. Let's go one step further and solve nothing, but it's still a bit better. Because using factory methods, you will be able to separate concerns, to separate the construction parameters from the implementation, right? So we use this factory method, and instead of just exporting the load user function, we make it into a factory, which is going to receive the profile store. That's good. We're getting there. We're stepping up a bit. On the provisions, we're basically exporting the function by calling the factory, right? It already gives you some flexibility, but it could be still better, because it gets cumbersome very fast. You can't be doing that every time. You can't be doing and calling it every time we need it. I mean, you could, but who really wants that? And nobody got time for that. So remember that here, we really haven't solved anything yet, because the UI is still depending on data, which, according to what we said, is a sideways dependency, so not bad, but also not good. So we can do better than that. So let's step it up a bit. Before getting to the next branch, which is the service locator, a kind of more complex solution, let's review this graph, which would represent the app. Let's say that feature 1 is the profile, and feature 2 are the trips. And here, right at the core, we will have the service locator as our strategy to inject the dependencies. So a service locator is basically a middleman between your dependencies, which is not that bad, because instead of interacting directly with the other ones, you're going to go to the service locator instead to retrieve your dependencies. So if we take a look at the dependency flow and which way it goes, right? It looks harder than it actually is, but it actually, it's not that bad. The dependencies go that way, and you can see that nothing is going up, which is good. And then, if you want to register your dependencies for the other components to be used in them, you register your provisions and use the set. And how are we going to do that? By defining keys. So you basically define some keys, however you like, and register them in the service locator. And then, if you want to retrieve one of those dependencies, you're going to use the get. Simple enough, right? That's good, because it doesn't break the downwards flow or our pattern at all, and components won't have to instantiate dependencies directly. But it does have a tiny problem that I'm sure at least one of you have noticed by now, which is that it breaks the inversion pattern that we have been preaching up until now, such preacher that I am. Because what am I doing? It's breaking the inversion of control. We're accessing the service locator directly. I mean, of course, it's an exception of the rule. It's just the service locator. But it really breaks, and we can fix it. We can achieve separation of concerns and separate the configuration from implementation. If you want to take a look at the repo, you can see the service locator branch and compare the changes, which is exactly what we're going to do now. No need for you to follow along unless you want. So first of all, what we did here is define our container with a more or less generic set and get, right? Then you define your keys and your provisions. You use those keys to register the dependencies, right? And then you are going to get the dependencies from that place. So instead of importing it or using it directly, you're going to call the service locator container to retrieve those dependencies by using the key. And of course, we can forget the setup, which happened to us and spent like 2 hours figuring out why it wasn't working. And it's because you have to register them for them to be available for everybody else on app level. So how can we step up and achieve like the ultimate dependency injection? You go to someone else's talk, but we can get closer by improving our current model. So basically what changed between the service locator and this dependency injection? Basically this with dependencies function that we have right here, which will allow you to separate config from implementation. So let's look at it again. This is the flow of dependencies, right? So instead of accessing the same thing to set your dependencies and to retrieve them, we're going to use the DI container for the set. And then if you want to retrieve some of the dependencies, you're going to use the with dependencies function to get them.
From the provision.
Of course. So this is great, because we managed to regain the inversion of control. We're good preachers again. So, and this could help you to prevent dependency cycles and cyclic dependencies, which is really bad and really nightmarish. And it could help you to detect configuration issues at compile time. If you have used Angular, you might have noticed this is already built in. But sadly, we are not using Angular. We have a mobile app, so we needed to figure it out on our own. Mm-hmm. The bad thing about this is that maybe it's too much if you have a small or medium project. Maybe you don't need it. So really take this into consideration and adapt it to your project's needs. So the code for this, basically the first thing we did was to regain our factories. You can also compare it in the dependency injection branch, if you like. Then we're going to use the with dependencies function that we defined here.
Barely.
More or less.
We're not experts.
We are not TypeScript experts. We have one person in our team who is. It's not us. This is homemade. Mm-hmm. But the basic idea is here. You get it. Basically, this function will look for all of the dependencies and make them available. Now the provisions will look like this, which is great. Of course, we renamed the I container, not a cell container anymore. And then we can access the dependencies within the UI. Okay? So we can access the DI container and get the dependencies that we need. But we can do better than that. Because what if we wanted to do that within the UI as well? And to that I say, yes, let's use Context API and serve some code. So we can use Context API for more than just like sharing themes or other stuff. We can actually make the DI container available to everybody, including the views, through Context API. So if we build it from the ground up and take into account the core layer, the features layer, and the app layer, we can do it. So first of all, at the core level, we're going to define the context to provide the DI container for everybody. And then, if you had the pleasure of being in the previous talk, we discussed HOCs, higher order components. Basically, they said they are dead, but they're not. They're not. They're alive and well. So we're going to create one, but not for the very thing that they were used before. We're going to use them for a purpose, which is to make the dependencies available. There's also the option of the hook. If you take a look at the branch for the Context API, we also created a hook if you prefer this approach, and the components can use the hook instead. But this one kind of looks cleaner and also showcases that we, again, are not TypeScript experts. As you can see, we called PS ignored. So then we can prepare our components for the I at feature level, right? And then we can export them by using the keys. And this is great because even though we chose very creative names like load trips and trip store, which is a variable name for load trips and trip store, you can call them however you want it instead. Like if you wanted to call them Pepa or whatever, you can. And this is great because it will translate to the props of this component. And then you can create the provider, never forget, on app level, so that everybody has access to this DI provider. You don't have to reinvent the wheel like we did. Why did we do this? So that we could give this talk. But you can use other external tools. I'm sure you are familiar with Inversify JS, or maybe not, but it's very popular. Please ignore the market crash from 2008. I don't know what happened during that month, but they are still very popular, like Inversify and tcrange. But they are not very much of use to us because they don't provide first-class supports for functions. And React and React Native are all about functions, so this really doesn't apply to us. Which is why we included this third option, Obsidian, right here, which was made with React in mind. So this is the reason why we included it, even if it's not as popular as the other two. Because otherwise you have to go and reinvent yourself a whole new framework like we did. So before we close, let's review one more example to answer the question, what happens, the question that nobody asked, what happens if my app scales? How do we maintain this inversion pattern? And it is possible if we respect the basic layers that we defined before. So let's start with the core. So each layer will have its own components, UI, data, and domain. And like we saw before, we can always ensure that the dependency flow will travel down. Then if we take a look at the features layer, we can have as many features as we like. And features will be using stuff from core, right? So maybe the domain from feature 1 will use stuff, right, from the domain in core, as well as feature 2. Or you can also make the UI use stuff from UI, or even from domain, which is also done by feature 2. You can even go sideways, right? So feature 1 would be requiring stuff from feature 2, which is possible. So for example, the UI, or even the domain. You can do that. And let's not forget our app layer, which will be using all of these components combined. So what will happen, I ask you now, what will happen if suddenly feature 2 needed to use stuff from feature 1? And to that I say, wait a minute, because all of these arrows are making me dizzy. So let's take a step back and recap to understand. Remember that core, features, and app are functional units of your project. So if suddenly feature 2 needed to use stuff from feature 1, we could be facing circular dependency issues, which are a nightmare, but it can be solved. You could have many solutions to this. One of them, to reconsider your life choices. I'm not saying it like a joke, but it sort of is. But like, really ask yourself, does feature 1 really need feature 2? Does feature 2 really need feature 1? Maybe the answer is no. Sometimes the answer is no. And boom, that's solved. But sometimes the answer is yes. So if the answer is yes, you could always create an intermediate service for both of them to depend on. And that way you can solve this horrible cycle of death. Or, of course, you can rage quit, become a farmer. We all have thought about it. I don't know if I would recommend it, but I'm not the boss of you, so you do you. But the important thing that I want you to remember today, the most important thing is that remember the dependency flow will always travel down, and sometimes sideways, but never up. That's the most important thing that I want you to remember today. In conclusion, inverting your dependencies is great because it will allow you to achieve our goal, which is a flexible domain that's as agnostic as possible to the outside world. If you do that, you will have a kind of domain that will allow you to replace third-party libraries as many times as you need and whenever you need, without affecting your business logic or product requirements. We can reinforce this by following solid principles, our beloved, of course. And if you apply good dependency injection strategies, you can guarantee that you will have a scalable architecture through the use of clean code, which we all know and love. Mm-hmm. So, after telling you all of this, if you're wondering, some Michael Scott moment right here. if you're wondering, do I really need this? If you're wondering if you need it, the answer is probably not. But maybe you do. So I hope this was useful to you.
Exactly.
So thank you all. I hope you like this.
Hola, gracias por la charla. Os quería preguntar si habéis implementado algún sistema de inyección de dependencias con Next.js, es decir, en un framework que tenga cliente y servidor. Que ahí lo he intentado alguna vez y es difícil, pero me gusta, vamos. O sea, yo lo intento. Otra cosa es que salga.
A ver, lo intento responder, ¿eh? Nosotros venimos de React Native, así que la respuesta en sí sería no, porque no lo hacemos. Los principios en sí no llevan ninguna librería, así que se podría intentar. Si va a funcionar o no, tengo una duda.
El problema es que el contenedor de dependencias
claro, vive
debería
en un
ser
lugar
el mismo
otro.
en cliente y servidor, pero no lo es porque una cosa es cliente, otra cosa es servidor. Entonces no sé si habéis tenido... Claro, si no lo habéis probado, pero vamos.
Lo puedo intentar en casa y vuelvo el año que viene.
Venga, eso, perfecto. Vale, gracias.
Nada.
Thank you very much. I think we switch up to English, to Spanish, but I don't know if there is someone speaking English. So we
Not
can
anymore.
switch.
They died.
Okay, it's okay to move to Spanish? Ok, perfecto. Tenemos una preguntita por aquí que está muy bien, voy a traducirla, que dice, bueno, si hay algún tipo de error de gestión de errores cuando intentamos cargar alguna key que no exista en el motor de dependencias y o en algún caso que haya dos implementaciones distintas de la misma función y quién es responsable de gestionar ese error.
¿Quieres responder o...? A ver, nosotros lo que hicimos ahí en la demo es básicamente llevar un setup, que es el que inicializa todas las provisiones, ¿no? Entonces siempre se hace de antemano. Es verdad que puede cambiar, en la demo no se mostró, pero la parte más que nada de UI debería ser flexible a eso y suscribirse ante los cambios. Sí puede pasar que no hayan, pero es un poco llevar la conciencia de desarrollo y probarlo, ¿no? Más que nada. Nosotros al menos lo hacemos así, manteniendo al punto de las provisiones.
Perfecto.
No sé si responde.
Sí, yo creo que sí.
Cuando implementas tienes dos implementaciones iguales de una misma clase, por ejemplo.
Sí.
O sea, por ejemplo, tienes una store, ¿no? User store, y la implemento en una vez y luego cambio, tengo otra implementación distinta.
Sí.
¿Cómo haría un componente para, sin cambiar la clave de la que estoy usando, saber cuál de las dos tiene que usar en la instanciación? Es decir, ¿quién es responsable de decirle, oye, pues tú usas esta otra, sin cambiar la clave de la que estoy usando, estoy cargando esa dependencia?
Al final es por key, por eso también es por composición. Te puedo dar el ejemplo con el high order component que hicimos. Uno mapea props a keys. Si vos querés generar un nuevo componente que use una nueva dependencia bajo una nueva key, lo suyo es crear como una nueva configuración de ese mismo componente. Por eso separamos la parte de configuración en las provisiones de la implementación de ya sea tu función, ya sea tu componente.
Vale.
Entonces uno va generando distintas configuraciones según la necesidad. Pero esa es la idea.
Más preguntitas. Preguntita por ahí. Yo te voy a hacer una pregunta. A nivel de gestión de memoria, uno de los problemas que tienen los service locators es que al final tenés que inicializarlos todos, incluso los uses o no los uses. ¿Utilizáis alguna estrategia para intentar hacer la instanciación de forma lazy o algo? ¿O sobrevivimos con eso?
A ver, hay patrones, no los mostramos, lo mismo, porque generamos nuestro service locator y nuestra inyección de dependencia a mano. Con las librerías eso debería estar más refinado y tenés la opción de manejar el ciclo de vida de cada cosa, ¿no? Siempre delegamos en la librería. Lo hacen mejor que nosotros.
Claro.